In this episode, we are shifting from general network visibility into a part of security work that focuses much more directly on the applications people use through browsers every day. Web application scanning tools are designed to examine websites and web-based services for weaknesses that could allow attackers to access data, interfere with business functions, abuse user trust, or move deeper into an environment through flaws in the application itself. For a brand new learner, it helps to think of these tools as specialized inspectors that do more than simply ask whether a system is alive on the network. They try to understand how a web application is built, which pages and functions it exposes, how it handles user input, how it manages sessions, and whether it behaves in ways that suggest known classes of weakness. That makes them very different from ordinary host discovery tools, because the goal is not only to see that a server exists, but to understand whether the software experience presented to users contains security problems that could be exploited through normal web interactions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A web application is more than a page of text on a screen, and that is one reason scanning tools for this area need to be specialized. Behind the visible interface, a modern application may include forms, search boxes, login pages, account settings, shopping functions, dashboards, uploaded files, background scripts, database connections, and application programming interface, API, endpoints that exchange data with browsers or mobile clients. Each one of those functions can introduce trust decisions about what input is accepted, what actions are allowed, what user is authorized, and what data is returned. Web application scanning tools are built to explore those functions in a structured way so they can discover where the software may not be enforcing security correctly. Instead of only asking which ports are open, they ask what the application does with a request, how it reacts to unexpected input, whether it exposes too much information, and whether the user experience hides weaknesses beneath the surface. That deeper focus is what makes web application scanning such an important skill area for analysts who need to understand modern attack surfaces. One of the first jobs of a web application scanning tool is discovery. Before a tool can evaluate security meaningfully, it has to learn what parts of the application exist, which pages are reachable, where forms are located, what parameters are accepted, and what navigation paths connect one part of the application to another. This discovery process is often called crawling or spidering, and it matters because an application can be much larger than what appears on the main screen when a user first loads the site. Administrative paths, password reset flows, user profile areas, search features, hidden parameters, and less obvious directories may all expand the attack surface. A strong scanner tries to map this application structure in a way that gives analysts a working picture of what is present and where further testing should focus. For beginners, this is a crucial point because vulnerabilities do not only live on the homepage or the login screen. They often hide in overlooked features, forgotten workflows, or little-used components that the organization has not reviewed carefully in a long time. After discovery, the next major task is interaction. Web application scanning tools do not just collect page names and stop there. They send requests, observe responses, vary inputs, and test how the application reacts when it receives data that is unusual, malformed, unexpected, or specifically shaped to trigger known classes of weakness. That is important because many web vulnerabilities arise from how the application processes input rather than from the simple fact that a page exists. A form field, a search bar, a cookie, a session token, or a parameter in a request can all become security relevant if the application trusts the data too much or handles it poorly. The scanner is therefore trying to behave like a very curious and systematic user, one who keeps asking whether the application validates data properly, limits actions correctly, and returns safe output under a wide variety of conditions. This does not mean the tool magically understands business logic the way a human analyst might, but it does mean it can explore many possible weakness patterns far faster and more consistently than manual testing alone. A major strength of web application scanning tools is that they are particularly good at looking for common classes of web-based weakness. These include problems related to structured query language, SQL, injection, cross-site scripting, XSS, weak session handling, insecure cookie behavior, missing security headers, exposed administrative functions, poor input validation, unsafe redirects, and other weaknesses that often appear when applications are built quickly or maintained inconsistently. The reason this matters for CySA Plus learners is that web applications are a frequent target for attackers because they often sit at the edge of the business and interact directly with customers, employees, or partners. A weakness in a web application can sometimes lead to data exposure, account takeover, fraud, or movement into deeper systems if the application has trusted connections to databases and internal services. Web application scanning tools help defenders reduce that risk by looking for patterns that have repeatedly led to compromise in real environments. They do not guarantee safety, but they do help make common weakness classes more visible and easier to assess. It is also important to understand how these tools differ from general vulnerability scanners. A traditional vulnerability scanner may focus more on server software versions, missing patches, exposed services, and host-level configuration issues. A web application scanning tool, by contrast, is much more concerned with how the application behaves through the Hypertext Transfer Protocol, HTTP, and Hypertext Transfer Protocol Secure, HTTPS, layer, how users interact with it, and how the business logic behind those interactions might create weakness. In simple terms, one type of tool is often better at telling you something about the platform that is hosting the application, while the other is better at telling you something about the application experience itself. Both viewpoints matter because a perfectly patched server can still host a dangerously flawed application, and a well-written application can still be at risk if the hosting environment is weak. Strong analysts learn to keep those layers separate in their thinking while also remembering that attackers do not care which layer the problem belongs to. If the weakness helps them succeed, they will use it. Authentication changes the value and complexity of web application scanning in a major way. Some scans are performed without logging in, which helps reveal what anonymous users or outside attackers might see from the public side of the application. Other scans are performed with authorized access so the tool can test what exists behind the login page, including user dashboards, role-based features, account settings, workflows, and administrative functions that are invisible to the public. That distinction matters because many important weaknesses live only after authentication has occurred, especially problems involving access control, role separation, transaction logic, and data exposure across user boundaries. A scanner that never gets past the front door may miss a large part of the real risk. At the same time, authenticated scanning brings new challenges because the tool must maintain valid sessions, navigate application workflows carefully, and avoid causing unintended changes in live data or business processes. For beginners, this is another reminder that visibility is shaped by where the scanner is allowed to go and what kind of user behavior it can realistically reproduce. One of the most useful concepts to understand is that web application scanning tools are often good at scale and pattern recognition, but less strong at deep human reasoning about business intent. A scanner can test large numbers of parameters, repeat similar checks across many pages, and recognize signs that often point to common vulnerability classes. What it usually cannot do as well is understand subtle business logic the way a trained human tester can. For example, a tool may identify a weak session cookie quickly, yet fail to recognize that a low-privilege user can manipulate a sequence of ordinary actions to gain access to someone else's records because the application's business rules are flawed. That does not make the tool weak or unimportant. It simply means its strengths are different from those of manual analysis. Good security teams know that automated scanning tools are best used as part of a broader assessment approach that includes human judgment, validation, and attention to the context in which the application actually serves the business. False positives and false negatives are especially important in this area because web applications can behave in ways that are complex, stateful, and sometimes difficult for automated tools to interpret correctly. A false positive occurs when the scanner reports a weakness that is not truly exploitable in the way the tool suggests, perhaps because a response pattern looked suspicious even though another control quietly blocked the attack path. A false negative occurs when a real weakness is missed, often because the tool never reached the right page, failed to stay authenticated, did not understand the sequence required to trigger the problem, or simply lacked the right detection logic. For that reason, analysts should treat scan output as evidence rather than absolute truth. The output is useful, often very useful, but it still needs human interpretation before major business decisions are made. This is one of the most important habits for new learners to build. Security tools can accelerate analysis tremendously, but they do not remove the need to validate important findings and think carefully about what the evidence really means in the application's actual context. Another major topic is the effect of modern application design on scanning results. Many older web applications were relatively linear, with pages linked in straightforward ways and user interactions that were easier for scanners to follow. Modern applications are often much more dynamic, using client-side scripts, asynchronous loading, rich browser behavior, and extensive API communication that may not be obvious from a simple page crawl. This complexity can make discovery harder and can reduce scan coverage if the tool cannot fully understand how the application loads content or changes state during interaction. It also means that some important functionality may sit behind scripts or behind sequences of actions that a scanner must reproduce correctly to reach. For analysts, this matters because a clean scan does not automatically mean the application has been examined completely. Sometimes the issue is not that no weakness exists. Sometimes the issue is that the application's design made certain parts of the attack surface difficult for the automated tool to observe and test effectively. Web application scanning tools also have to be used responsibly because they can affect the systems they examine. Repeated requests, large crawl activity, aggressive parameter testing, and authentication-driven exploration can create load, fill logs, trigger alerts, or interfere with fragile or sensitive parts of the application if the scan is not planned carefully. In a production environment, that matters because the application is often serving real users and supporting real business activity while the scan is underway. Security teams therefore need to think about timing, scope, rate of requests, alert coordination, session handling, and whether some actions should be excluded to avoid unintended consequences. The goal is to learn about the application without creating avoidable disruption. For beginners, this is another important reminder that security assessment is never just an abstract technical exercise. It is an operational activity performed against real systems with real users, which means even a well-intentioned scan needs discipline, planning, and respect for the environment in which it runs. These tools are especially helpful when they support repeatability. A web application changes over time as developers add features, fix bugs, redesign interfaces, connect new services, and modify workflows to meet business needs. Every change can introduce new weakness or reopen old problems that were thought to be solved. Repeated scanning helps organizations keep pace with that change by checking whether the application still behaves securely as it evolves. This matters because security is not a one-time inspection performed before launch and then forgotten. It is an ongoing effort to ensure that changes do not quietly erode protections over time. A web application scanning tool can therefore act as an ongoing source of visibility, helping teams compare results across releases and notice when the security posture is becoming stronger, weaker, or simply more complex. For a CySA Plus learner, this reinforces a broad truth about vulnerability work. Real defensive value comes not only from finding a flaw once, but from creating a process that keeps the environment under continuous review as it changes. The most effective use of web application scanning tools usually happens when their results are interpreted alongside other kinds of information. A finding about an input validation problem becomes more meaningful when the analyst also understands what data the application handles, which users rely on that function, how exposed the application is to the internet, what kind of privileges the affected feature has, and whether monitoring already shows suspicious activity aimed at that part of the site. In the same way, a technically serious finding may need different urgency, depending on whether it affects a public customer portal, an internal reporting page, or a rarely used development function hidden behind strong access restrictions. This is where context-aware analysis becomes so valuable. The scanner helps identify patterns and potential weaknesses, but the analyst must still decide what the result means for the business. Strong defenders do not stop at the scan report. They connect the report to application importance, exposure, user role, data sensitivity, and operational consequence so remediation decisions reflect real risk rather than simple tool output. For a new analyst, it is worth remembering that web application scanning tools are part of a much larger effort to understand how software creates attack surface. They help with discovery, input testing, session review, and recognition of common weakness patterns, but they are not substitutes for secure development practices, sound architecture, good access control, or human validation. They are most valuable when they are used regularly, scoped intelligently, interpreted carefully, and tied to an organizational process that can prioritize and correct what matters most. When those conditions are in place, the tools give defenders a practical way to keep watch over one of the most frequently attacked parts of modern computing. When those conditions are missing, the organization may still produce scan reports, but it will gain far less real protection from them. That difference is important because cybersecurity is not about collecting evidence for its own sake. It is about turning evidence into safer systems, better decisions, and fewer opportunities for attackers to succeed. The big takeaway is that web application scanning tools are designed to help defenders examine how web-based software behaves, what attack surface it presents, and where common classes of weakness may exist within that behavior. They are different from general network scanners because they focus on the application layer, user interaction, input handling, session management, and the logic that connects requests to real business functions. Their strengths include broad coverage, repeatable testing, and efficient discovery of common web weakness patterns, while their limits include incomplete understanding of business logic, imperfect coverage in complex modern applications, and the need for human validation of important findings. Once you understand those strengths and limits clearly, you begin to see these tools for what they really are, not magic detectors, but structured assistants that help analysts inspect one of the most exposed and business-critical parts of the modern environment. That is why they matter so much in vulnerability work, and why learning how to interpret their results is a foundational skill for anyone preparing to think like a capable defender.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.